Hello, I'm William. I am a developer advocate at OneSignal, and with me I have my colleague Rodrigo. We're going to be going over types and creating TypeScript declaration files for your JavaScript stuff that doesn't have TypeScript support. Um, Rodrigo?
Sure, yeah, I could talk a little bit about what I do at OneSignal. I'm a software engineer at OneSignal. I work on the SDK team. So I work a lot with building all the libraries for OneSignal and all the tools that developers use to integrate OneSignal with their applications. And yeah, so I have some experience working with TypeScript, especially with our web SDK.
All right. So I kind of want to give like this is part of our intro, by the way. So when you cut it. So I want to give kind of a motivation for this workshop. Many people have a lot of experience with JavaScript, but TypeScript is quickly becoming a language of choice for most corporations, as well as startups, mainly because of the support that you get while developing. You will know at compile time whether or not your program is correct. It doesn't necessarily mean that it's going to behave correctly. It just means that you have some sort of confidence in the correctness of your program, so that if it does compile, at least it's going to run and hopefully not result in runtime errors. So because we work at OneSignal and we produce SDKs. Part of our mission is to improve the developer experience for the people using our products. And as a result of that, TypeScript is a natural fit, because if you're using JavaScript or even TypeScript, like having those typings is useful, especially if you don't know anything about the project. It's one thing to have documentation. It's another thing to have documentation in the form of IntelliSense when you're in your IDE, so that when you do control spacebar or whatever you're on and your OS, you get some kind of indication or type hinting about what's possible, as well as what parameters you need to pass to a function, or what the shape of an object is supposed to be. And JavaScript doesn't really give you that, but we can add that using TypeScript declaration files. Now, because TypeScript is a superset of JavaScript, we don't actually have many of the tools that we would be using in TypeScript in JavaScript land, and we can actually add that by these declaration files. But before we do that, we need to get into types, because at the end of the day, a declaration file is literally just a file of types. So we'll kind of go over, what are we going over? I forgot. You can edit that part when I say I forgot. Anyway, let's
We
just
can
jump
we
in.
can we can go through the README that you put together
Okay.
and go over some basics about, regarding TypeScript
Okay. All
um,
right.
before jumping into like some code. Yeah.
I think that's a good idea. So for those of you who are in this workshop, please understand that this is a very weird workshop for us. Typically, a workshop is in person. We get to work with you in person, and we can see your facial expressions. You can ask us questions when you're not understanding. Because we're both looking at computer screens and cameras, we don't really get that interaction. So a lot of this is kind of like, you're going to kind of hear us banter back and forth. We're going to leave this in, because I think that it's useful. It'll give you a better experience, in my opinion, that's more in line with what you get in real life. So just keep in mind that this is a very weird structure for a workshop, but we're going to do our best. And we'll also leave some contact information. There'll be a repository. Feel free to leave issues if you have questions, or if you just want to drop a comment, just drop it there, and one of us will respond. But let's kind of get into this. And in order to do that, I think I should share my screen. We're going to see how this works. Yeah. All right. So we have our project open, and what I think I'll do is I will create a runtime file that we can use to kind of just play around. All right, so yeah, we're kind of here. So yes, I guess we'll start with these types. So we'll kind of jump in. Let me make sure I have battery and my thing. I think we'll be good for a while. All right, so let's get started. All right, so as I was saying during our intro, is TypeScript is a superset of JavaScript, and what that means is all valid JavaScript is also valid TypeScript. But we also want to take advantage of the power that TypeScript gives us, and that's in the form of type annotations. So we're going to go over the primitive types, as well as some reusable types, as well as a few of the more common advanced types. And the reason behind this is that when we're creating our declaration file, in reality, all we're doing is we're adding types to functions and data. So it's important to understand how this works. And once you understand how this works, like the declaration file is pretty simple. It's mostly configuration. So we're going to start with the most simple type, which is a string. So I'm going to just type in a const, and we'll call it s. And I'm not going to give it a type right now. I'm just going to do this as a string. So first thing to know about TypeScript, and this is something that you get when you are developing. You don't really get this in your declaration file, but part of building a declaration file means that you will start to get what I'm going to start to show. Type inference is something that allows TypeScript to understand what type of data a variable can contain, like what value it is. So in this case, we're using a double quote that indicates that this is a string. So if I were to do something like, I guess type of, can we do that? Just type of s equals string. what would you expect to happen here?
This should be true.
Yes. So note that I didn't actually specify that this is a string. And that's because of inference. We're actually not going to be using inference during most of this workshop because, again, we're talking about declaring declaration files. So I'm just going to do a little bit of extraness to say that this is a string. Note that it doesn't change anything. At the end of the day, all of this compiles to JavaScript, so it's still going to be like the normal JavaScript string. But during design time and as well as compilation time, we know that we can be assured that if we call like to uppercase, it's not going to be a number. So I think that's fairly powerful because it's something that you don't get in JavaScript, where, you know, if you do this is a string, but later on somehow you reassign it to a number, and then you're like, oh, number dot to uppercase, you're going to get some type of error. So this is a good way of preventing that. I don't think
these are primitives, so
yeah.
I mean, the example is you know, with primitives, but obviously when we start working with some more complex you know, objects, then you may want to make sure that an object is of a certain type before doing something interesting with that object.
Exactly. And to build these more, I guess, complex objects, we do have, you know, they're basically built out of primitives. We're going to get to that very quickly. We're not going to spend much time on strings and numbers. I just want to go over them just so that you're aware what they are. And when I say you, I'm not talking about Rodrigo, I'm talking about whoever's watching. So let's create a number. Const n. I think that's a fine name for a number. So we'll say n is equal to 10. And what would you expect the type of n to be if I were to just do this? Like, what should I put here?
Should be a number.
Number? Yes, it's a number. So I'm just going to put number here. So now we know that, what? So now we know that n is a number. TypeScript already knew, but now we know, which is more important, I think. What's another primitive that we should cover, or that we can cover?
Boolean.
Boolean, okay. All right, so we'll call it b equals, where do you want to go, true or false?
Let's go true. Stay on the optimist side.
Cool, cool. We'll go with that. So we'll do the same little like song and dance. We'll say type of b, and it's going to be Boolean. Notice that it's not bool. In some languages it's bool, but here's Boolean. And if I write that out, of course it comes back as true. So true is what we're getting here. What's another primitive? We have string, number, Boolean. What's some other ones that we can cover?
Hey, Will, can we make the text editor a little bit bigger?
Sure. Yeah. Sorry about that. How's that?
Can you go one more? Yeah, that's even better. Okay,
right.
Perfect.
All right, let me move that.
We could do object as another JavaScript primitive.
Okay, so let's do const o, and we'll just do an object, or empty object. I'm using a literal. This is object literal. Of course, we can add more properties and keys, but just for demonstration purposes, we're going to keep it simple. So we'll just say type of o, and what should it be? Object. And let's see what we get back. I think it's going to give us what we think, true. We've been saying a lot of trues. I want to see a false. Let's see if object is a number. Okay, that's false. Okay, all right, cool. How can we break this though? I want to see how we can break this.
Mm-hmm. Well, let's try to do something with one of these variables that would not make sense, right? Like, I don't know if there's going to be, like a warning shown in this editor, but once we do get to VS Code, we'll see like some warnings that are highlighting something saying like, oh, you can't actually do this. So maybe let's try something like that.
Okay. I'm going to change this from a const to let so that we can reassign to it. And
okay.
let's try and set s to n, which is a number. So actually, I'll just do a number like this. Look, we do get an error. Type number is not assignable to type string. So TypeScript is doing its job for us. It won't let this compile.
Exactly. So now let's maybe change the type on s and see what happens then.
All right, I'm going to change this to number. All right, now s is giving me an error, and it's like, oh, well, this is a string, but s needs to be a number. So I guess we'll fix this by setting this to a number, 0. Seems to be pretty good. So it's 0 here, and let's see what it is here. It's 10. So that went off without a hitch.
I think this might be a good time to introduce the magical TypeScript keyword any. Maybe let's change the number type on s to any, and then set it back to the previous string that it was. Yeah. And then we will see that we should not get any errors, even though we were sort of reassigning it to a different primitive here on line 6, being 10, which is of type number.
Yes.
So do you want to talk a little bit about what the any keyword is, Will?
Yeah, any is literally any type in TypeScript fits under any. That means that it can be a Boolean, it could be undefined, null, it could be a symbol, it could be anything. And if you really think about it, any is the same types that are in JavaScript. So if you create a function and it has some parameters, everything, I mean, if you're thinking in TypeScript, everything is any. So it could be anything. And here is a prime example of like an error of what can happen where, we started off with s being a string here, but then later on we assigned it to a number. And you can just imagine if you had a function that expected s to be a string, and then at some point you reassign it to a number, and then you call that function. Well, now you're going to have a runtime error, and that's what these types allow us to avoid.
So is it a good idea to use any?
No. The only time I actually would use any is when I don't know what the type is going to be. But there's also another special type. We're not really going to get into too much detail about this one, but it's called unknown, which just means that you don't know what the type is. And if you're ever working with APIs, sometimes you may not know what you're going to get back. And that's a good use case of using either any or unknown. How was that description? We're good?
Yeah, it's great.
Okay. All right, so we have a few primitives. We have a string, number, Boolean, object. We also have, I wouldn't call it a primitive, but let's just call it a primitive for sake of demonstration, arrays. So let's say const a is equal to this, and I'm using what do we call this? An array literal syntax. Let me go ahead and add these typings here so that we know what they are. So we'll do this. This one's going to be interesting. We're going to come back to this right here, this object. That's interesting. And we're going to use array. Can we not use array? So we have to use array. We don't know what's in this array right now. This is an example of, what do you call these things? What are they called? Generics? Yeah.
Oh, yeah, generics. Yeah.
Yeah, this is an example of generic, and you can almost think of a generic as a variable for types. So whatever we put in here is going to kind of like restrict the types of things that we can put in this array container. I don't really want to restrict what it's going to be right now, so we're going to use our keyword that we just learned, any. And I'm going to come back up here and set this to string, which is going to cause an error down here, so I'll just delete all that. So now we have an array of any, and what that allows us to do is we can push values into this array. We can put the number 5. All right, that's cool. Actually, I'm not even going to put the number 5. I'm going to put s, and then I'm also going to push n, and then I'm also going to push b. Oops. So if I look at this array, it has like all kinds of different data in there. And if you're coming from a strongly typed language, this might be a bit of an alarm. Like this may be setting off alarms in your mind where it's like you have no idea what's in this array. And that can be dangerous. So how should we constrict this? Like what type should we put here just to see what kind of errors we can get?
Well, let's say that we just want to choose maybe 2 of the types and exclude the other ones. So let's say we only want to accept Booleans or numbers.
Booleans
how
or
sometimes
numbers.
A number can be a Boolean, like 0 is false, 1 is true. So maybe for whatever reason we want to accept both types, and we don't want to accept strings, right? So how would that work?
Okay, so there is this concept called a union, a type union. You can think of those as an OR, a logical OR. And the way that we would go about that is we would say number, and we're going to use a pipe, just one pipe. That stands for or you can say or, and Boolean. So now, this s is not kosher. This is a string, so we can't put a string in something that can either be a number or Boolean. So we'll just comment that out. So now we get 10 and true. Okay, well, I do want to cover 2 more types. They're kind of special. We have null and undefined. In JavaScript, these are actually values, which means that in TypeScript, they're also values. But we also have in TypeScript the type for that value. So they're actually the same name. So if you have null, the type of null is null. If you have unknown, the type of if you have undefined, the type of undefined is undefined. So we can kind of do that. We'll just say const u, we'll say undefined. And then let's try to set that to null. What the? Okay. It's interesting. This is one of the things about the type system. We'll get into this a little bit later. Let's also set this to undefined. Undefined. And that's also fine. But let's try and set this to...
I think that might be more of a quirk of JavaScript.
Yeah, it is.
For anybody who's familiar with JavaScript, you will know that JavaScript has a lot of things that act in ways that you wouldn't expect. This, I think, might be one of those things.
Yes. But there is an option in the TypeScript compiler called strict null checks, which I think would fix this, but it's fine for now. Like what Rodrigo is saying is in fact true. Like undefined and null, they can kind of be treated the same way. Like you could use coalescing, or not coalesce. Is it what is the thing where you have a type and like JavaScript will just be like, oh, I know you said this type, but I'm going to convert it to this other type, casting or something like that.
Casting, yeah.
All right, let's also write out the other type. We'll call this n null. We'll just call it null or nil. How about that? I like nil. We'll say that's equal to null, and we'll say null. And I'm also do a let here, just so we can reassign these, just to show that like it can't be anything else. So if we say u is equal to false, it's not going to let that happen. Apparently, not apparently, you can only assign null or undefined to either of these. So let's go to nil, and we'll say, well, that's equal to null. Let's try to set it to undefined. It allows that. But if we try to set this to a string, it's not going to let that happen.
But I think you are right in the sense that like in the TsConfig, so the TsConfig is sort of a JSON config file where you can sort of decide what rules you want your TypeScript compiler to use. And so this definitely might be one of those things where you can flip a flag in the TsConfig file in order to make TypeScript catch some things and not others. So if you actually want to make the distinction between undefined and null, I mean, I guess from what Will is saying, it sounds like that's something that you can do there. But TsConfig, that's definitely, I don't think it's something we're going to go over here today, but it's just know that it is sort of a powerful way for you to customize the way that TypeScript works in your project.
Yeah. Yeah, exactly. All right, so I think now it's a good time to kind of switch gears and zero in on line 4. I'm going to delete everything else because this is an interesting line right here. Right now, we're using the primitive object, which means that if we were to add like if we wanted to add keys or whatever, we wouldn't actually see those keys with IntelliSense. And I'll show you what I mean here. So let's just say we're going to have A, and A is going to be equal to the number 8. This is fine, but remember, this is typed as object. Object doesn't really have a key called A. Now, if we do this, notice that we're not getting any completion here. Although when we evaluate this line, we do know, or we see that it does in fact have a key of A. Now, the reason why this is happening is because we're using a primitive object. Now we're about to get into how we can actually define, like reusable types, and we're gonna kind of like transition over into a type alias so that we can make this a little bit simpler. If you don't know what I mean right now, that's fine. You will in just a moment. So let's go ahead and create a typing for this particular type. I'm gonna go ahead and actually I'm gonna turn off Copilot right now. It's gonna keep trying to suggest things. Is it off now? Oh, it's disabling. I guess it's gonna take some time to disable. But we want to have a key called A, and we want it to be a number. So let me format. So now I have this ugly declaration here where, if I want to get my IntelliSense, I have to do that. And you see I have .a here now because now TypeScript knows that, yeah, it's an object, but it's a special kind of object. And if I do this type of O, and I say if it's equal to object, I should get back true. And I do, in fact, get back true. Now, hopefully, you will agree that this is a little bit difficult to read. Like when you say, but you want to read this, Rodrigo?
I would not. Yeah, I mean, it's kind of hard to understand like what's even going on there.
Yeah. Well, this is one of the areas where reusable types come in handy. We have a couple of options here. We're going to start off with an alias, a type alias. The way we create that is we just say type, and we have to give it a name. I don't really know of a name right now, so I'll just say my obj, and we're going to set that equal to this. Here, I'm just copy and paste it, or I'll cut and paste. How about that? And in place of the type annotation that I did in line, I'm just going to say my obj. And now we get the same thing. I think this is a little bit better to read. How about you?
I think it's a lot better to read. Well,
yeah, you wouldn't fail my code review if I gave you this, but the other one you would probably be like, nah, can't happen.
Yeah, I would not let the other one fly for sure.
Okay, well. Let's change this to something else. Like, what's a good name that we could use here? Like, should we use what we have in our example here? Maybe we can use this API response that we have somewhere. Here, we can use this. Let's say that this is an API response. Actually, we're not going to do that. I'm going to keep it here for now. I want to kind of get into another type or reusable type, and it's called an interface. We can accomplish the same thing using an interface. So we'll say my interface, and I guess Copilot won't turn off, so we'll just go for it. And we're going to define it to be the same as my object. And I'm just going to replace that, and it still works. It's still an object. Now,
so what is the difference, Will?
Well, the difference is really about how you go about composing this or extending this. For all intents and purposes, they're the same thing. There's just one key difference. A type is close to extension. What that means is that once you create it, you can extend it. Whereas an interface is, once you created it, you can extend it at any point. So like there's nothing stopping me from also coming here and doing like, interface my interface and putting a B on it, a B string, not strong, B string. There's nothing stopping me from doing that. And notice that I'm getting like an error here because it's like, oh yeah, well, you're missing a B. So if I put B and I put 8, wait, why did that not? Oh, it's not, okay, my bad, test. So now it works. So notice that I have these two interfaces, and one has a number and the other one has a string. And when I call my interface down here, I had to pass both. This is an example of me extending the original interface. This comes in handy a lot. The thing is that you can't do the same thing with a type. So let's try that. Let's just delete this. And I'll also delete this so that we won't have a compile error. I'm going to create another type, and I'm going to call it my obj. I'm going to try to call it my obj. And, I get a duplicate identifier. Can't do it. So that's the key difference. You cannot extend a type. Types, once you create them, they're created. There is a way we can get around this, though, and that's via creating a new type. That's the composition of the old type and new types. We call these intersection types. So I can kind of emulate, what I did with this interface where I had my interface where I had a and a second my interface where I had a B. I can kind of emulate that. But remember, we can't create we can't like extend the types. We'll have to create a new one. So let's do that. We'll say type my obj2. We'll just call it my obj2. And that's going to be equal to my obj. But we're going to use this ampersand here, which means that we're going to do an intersection type. And now we can add our new property, B string. Now, if I come here and I take this typing and I put it here, notice that I get an error now. And it's saying that I'm missing this type string right there, where it says property B is missing the type, but it's required, B string. So let's go ahead and make that work. So now it works. And this kind of like highlights the fundamental difference between a type and an interface. It's a type, once you create it, it's created. You can't change it. And you can't have multiple definitions of the same type. Whereas with an interface, you can extend it by either having multiple definitions of the interface or using the extends keyword. I'm actually going to show how you can do it with the extends keyword. So let's we'll do another interface. We'll say interface my interface 2, and we're going to use some special keyword called extends, and we're going to say my interface. So now if I put B string, I now have an interface that is an extension of this previous interface, and I can just put this here and notice that it still works. So use interfaces most of the time. That's the lesson in this. Most of the time you want to use an interface, but types are also very useful, especially when you don't want them to be changed. So if you're writing a library, maybe you have certain things that you don't want the caller or your end user to be changing because maybe your library requires certain things to be the case, whereas maybe you expose certain interfaces where it's open to be extended and it's okay for you.
So I have a question, Will.
Yeah.
How can we make it so that the constant O can take A or B?
Constant
or
O
both.
can take
Or
A
both. Yeah.
or B or both. Okay. So first things, I'm going to delete these types here. We're going to use interfaces for here, and I'm also not going to do the extending here. I'm just going to move this up so that it's in one type, and we'll delete that, and we'll just delete 2. So if I wanted to have any one of these be optional, I can put a little question mark right here. I can also put a little question mark right here. So what this means is that I can pass in an A or a B, or I can pass in a B and not an A, or the other 2 permutations of this. So if I delete here, it still works. It's fine. Even if I don't add anything, it's fine. If I just add a B, it's fine. Notice that it still understands what the type of B should be. So if I put 7, it's not okay with that because it's like, no, B has to be a type string. So this is pretty useful because there might be certain functions that you create or just like certain data types where like it doesn't have to be there. And in cases where it's not there, it's typically undefined. So let's show what I mean here. So if we do 7 as a string, and we do O.B, oops, not B, A, we should get back undefined, like so. Does that kind of make sense a little bit?
Makes sense, Will.
Okay. All right. All right. Where should we go from here?
Let's go into functions.
Functions. Okay. All right. I'm gonna remove this so I can make the screen bigger. I want to zoom in a little bit more. All right. I'm gonna delete all this. We're done with that. Let's do a function. Let's do a simple function where we just add some stuff together. I think that's always a fun one. Oh, and GitHub Copilot. Okay, sure. I'll take it. All right. Let's add something. Let's add Rodrigo. How about that?
I'm honored.
And let's add a Boolean. Like I like Booleans. Huh. Rodrigo false. Now, so this is this is where like types become powerful, because when you create functions, you tend to want the data to be a certain type of data, or you have the expectation that what you're getting is going to be what you think you're getting. And right now, A and B are implicitly typed to any. If I hover over it, it says has any type. We don't know what it is. So that allows me to put Rodrigo and false. That allows me to also like do an array of false. I can add this. That doesn't really make sense. So how about we add some typings to this? Just do a little bit, just a little bit. Do a number. Okay, all right, look, we get an underline. Okay, let's fix that. Let's fix that underline. All right, so, oh, we still get 5 false. Okay, it's interesting. Make this a number. All right, we get another error. So, I feel like that's what we want, because it's add. I feel like that's really what we want. And yeah, like this function, now that we passed in number and number, TypeScript can infer that the return type is a number just based off of what's happening. We're using this plus. So if I hover over add, you see that it's number. But since we're going to be doing these declaration files, we need to be a little bit more explicit. So I'm going to give this function a type annotation of number. Actually, you know what? I'm going to change this from number just so I can show an error string. Now we get this. So we can use type hinting not just for developers who are going to be calling the function. We can also use it for ourselves, where it's like if we put the definition up front, we can kind of be guided by our type system. And this right here is the best example of what we're going to be doing in our declaration file, where we can just write this so that whenever we're implementing this, or if we're adding this to a JavaScript implementation, we know for sure that like it's going to do the things that we expect. So I'll put this back to number so that it's not failing anymore.
And again, this is a pretty simple example, but once you get into functions that are many, many lines long, you may miss, like, for example, with a switch statement or some conditionals, you might miss a case in the code path where you're not returning anything. And luckily, TypeScript will catch that, but you do have to actually say, okay, we're expecting this function to return this type.
Right. I want to show an example of that, actually. So let's say that we only want to add numbers if A is bigger than 0. So we'll say if A is greater than 0, and actually we'll say if it's less than 0, we just want to like return. Just return. And let's do it on a separate line. And why is this working? Or is it working?
Try putting brackets around the conditional. I don't know. It might be a quirk of this. Yeah, I'm not sure actually. This shouldn't be working.
Well, I know why. I know why it's working, and this is where your compiler options come into play. I don't have strict null checks here, so like I really can't. So in JavaScript, you can assign null and undefined to anything, and that's also the case in TypeScript, unless you have strict null checks enabled. Unfortunately, in this tool that I'm using for this workshop, I don't really have a way to control that, or at least I don't think I have a way of controlling that. But you just have to take my word for it.
Yeah. Okay. But this is something that you would change in the TsConfig JSON file. Is that correct, Will?
Yes. Yes. And I'm going to make it fail right now. I'll just say we'll return a string. And now it's like, you can't do that. String is not assignable to number. So I just made it fail just to prove a point. But if we had null checks on, then this would work. Or I'm sorry, this would fail. Or this would fail as well. So I'm going to go ahead and delete that so that we can go back to having working code. I also want to show how you can do these same annotations using the arrow syntax. I know a lot of people are into that. So let's create another function called subtract. And we're just going to call that sub. And that's going to be equal to A number and then B number. I guess I could just let this do it for me. And then we'll say B or A minus B. How about that? We'll just do A minus B. So it's the same thing for the most part. I can do sub, and now I get -7. I get -7. So you can do this in several ways. And also, I kind of want to show how you can type a variable as a function. So let's see what that's like. So instead of having it where it's like, oh yeah, this is equal to that, I am actually going to say, well, you know what? This is going to be a let kind of thing, and we'll type this and we'll delete the rest. Sub number, and then I need to do that here. So this is how you do a type annotation for a function. Now this is going to look familiar, or this we're going to see more of this in our declaration file. So when I look over here, it's like, oh yeah, this is a function that takes 2 numbers and returns a number. So if I were to try to do sub is equal to, let's create another function first. Let's say function s, and that's going to be something that takes in an A, which is a string, and then a B, which is a Boolean. And it's going to do something. I don't know, it's going to do something cool, I guess. Well, let's try and assign S to sub and see what happens. We get an error. It says that type, this function, A string Boolean void, is not assignable to type A number, which is indeed what we expect. That's what we want. Now, you may be wondering, like, why would I ever do this? Well, chances are if you use JavaScript, you use the callback. And it would be nice if you can express, like, what type your callback is expected to be so that when the library writer calls your code, it actually behaves as expected. All right, so hopefully that wasn't like too into weeds. We'll do more of that when we get to our actual declarations. All right, I think right now is a good time to talk about void because we just saw void as a return type. If you've ever used another programming language, are you familiar with C# or Java or any of those other languages that may use void?
Yeah, yeah, I've used some Java. I think does C++ use void? I've used C++ before.
I think so. I haven't used C++ in like 5 or 6 years, but I think it does. Well, we can kind of express the same thing here. So void, think of it as like something that doesn't return anything. It's just like it returns, but like it doesn't return anything. You can almost think of it as undefined. So like whenever you return in a JavaScript function, it implicitly returns undefined if you don't return a value. So void is just a way of describing that. Instead of saying return undefined, you just say void, and that allows you to just do a return in your function. And just to show what that's like, we'll say sub is equal to AB, and we'll just do a return. So it's happy with that because it just returns nothing. But if I say number, all of a sudden I get an error where it's like, oh, you can't do that. All right. Where should we go next?
Do we want to jump maybe into all the types?
All the types. Sure. I think let's try.
I think that we've covered kind of the basics. We can move into the example project.
Okay. So in this example project, it's pretty straightforward. It is a command line interface. Right now, there's nothing here. We have a command called all the types, and as you can see, we do have Lodash pulled in. Lodash is a very popular JavaScript library. There are typings for this. You can find them, but we're not using them here. We're going to create our own types for this, just to kind of like demonstrate creating a declaration file. So is that fair? Does that sound like a good deal?
Mm-hmm.
Okay.
Yeah.
All right. So we already have this kind of set up, but we'll be doing this again for our little custom library that we've developed just for you watching this workshop, so that we can add these typings together. But for now, we're going to use a popular library just as an example. So let's kind of go over the structure of this project.
Sure. Yeah, okay, so here we have, as Will mentioned, a declaration file. Essentially what we're just doing here is this is what we call a module augmentation. So we have this existing library, Lodash, that comes, it's a very powerful library. It comes with a bunch of tools that you can use to do some interesting things with arrays and various things in JavaScript that you may need to do. And all we want to do here is we want to sort of add our own typings to that. And so that's what this is here. So there's a function called chunk within the library Lodash. And all this line is doing here is we're sort of changing what that function takes so that we can make it even more specific than just the generic chunk function that comes with the library. So although we're not changing the implementation of the function, we are sort of making it fit our needs so that our TypeScript compiler can sort of catch things that otherwise it wouldn't. Does that make sense?
Yeah, it does. I'm curious if you can kind of like walk through like this what do we call this again? I forget the word.
It's a generic. Yeah. So
yes.
Here, this is essentially a way to add a generic to a function. So after the function name, you do open caret t. In this case, is kind of like the standard generic key letter in this case. And then once we define what the generic is, then we can use that in like the argument list or the return type. And this is essentially us adding some limitations to the types that can be added to the arguments or the return type. So because this is a declaration file, we wouldn't actually sort of be putting it here. But once we actually go and actually use the function chunk, we would essentially, when we invoke it, we would essentially declare which type we want to fit into those slots. In this case, it would be the first argument and then the return type. So say that we want our array to be of type string, then we would write chunk, open caret, string, close caret, and then we would invoke it with an array that should only have strings, and we can expect this function to return an array of only strings. Does that make sense?
Yes. So I can almost think of this as if like if I put any variable, like any type here, every occurrence of t will be replaced or substituted with that type. So if I put string
Correct.
here,
Yeah.
these are all string. Okay. All right. So
And,
let's see
and
that.
just to be clear, we didn't go over this earlier when we were working with arrays, but this is sort of a different way to declare an array type. Here we're having a t with a open and closed carets, like an array, or not carets, but the brackets, like an array. That would be essentially the same thing as doing like array, capital A, array, open caret, and then defining the type inside of that.
Like this. So just another way of doing it. This.
Exactly.
Yeah.
Exactly.
So instead of doing this, we're using the array literal syntax. So we can just do this. And yeah. Okay. Cool. So let's see this in action. Let's go to our little all the types file, and do we have any chunks anywhere when we're using this?
We should, yeah, right here on line 51.
Okay.
So I guess before we jump into this, like maybe we should just go over what this file is.
Okay.
Do you want to talk about a little bit about that, Will?
Well, I can give a high level of just like what the
Yeah, talk about the CLI, and then I can talk about the animals and the library.
Okay, cool. So we're using a library called Glugon, which allows us to create CLIs with minimal effort. And as part of this, we can create commands. And this command is just called command, and we're going to export it down here. And this command is just an object. And as you can see, it's a Glugon command. And if I look at the typing, there's needs to be a name. That question mark, that's a hint. That means that it's optional. Description, optional, but it has to have run. And if we look at the annotation for it, it's a function. It's a function that takes in a toolbox, and a toolbox is tcontext. We can actually go and look at what that is, but we don't need to for right now. And it returns void. So that means that it's just a function that does something. It doesn't have to return anything, or it won't return anything. And we have all these other things that are also optional that we can also add. So if we come back to here, we see we have name, which is optional, and we have the one required argument, or the one required property that must exist on this object. And it's an async function that, this callback, this toolbox, that is the type that we just saw, which is the, I think, tcontext. And yeah, we're pulling out some functionality from within our context. And maybe I should go back and show what tcontext is here. Oops. Oh, extends toolbox. Here we go. So toolbox, look at that. It's extending an empty toolbox, and these are all of the things that exist on that type that we can just pull out. And I think the thing we were pulling out is print, which is Glugon print. All right. So I think that's a good enough explanation for now.
Yeah, for sure. And one thing I would just add is one very cool thing about TypeScript is like, say, for example, I had never used Glugon before. By inspecting the types that come with this library, you can sort of get an idea of what certain things are doing without actually looking at like the source code. Depending on if the names of the functions are written in a way that it's clear and that sort of thing. But just an example of how another powerful thing that you can do with TypeScript. So this example project is essentially it's a very simple project. All it's really doing is working with these animal objects. So here on line 11, the first thing that we're doing is we're just declaring an empty array of animals, and then we're going to get a bunch of random animals. So in this case, we're going to push onto that array of animals 100 different random animals, and the random animal is this library that we mentioned earlier. And then below that, we're going to print some information about these animals. So for example, how many birds do we have, right? So on this animal object, there is a group, and each group is going to be bird, mammal, fish, or reptile, and that's how we're essentially classifying which group the animal belongs to. And then we are going to essentially filter we're going to filter out the animals of every type into their own variables. In this case, like for example, all reptiles or all birds, and then we're going to essentially print how many birds we have. So pretty simple. And then if we go down, then that's when we start getting into kind of how Lodash comes in. So chunk is a interesting function that comes with Lodash. Essentially, do you want to bring up the documentation?
Yeah.
And while you guys are doing this, I'd encourage you to bring up the Lodash documentation to get a better sense of what each function is doing. But yeah, so as you can see, it essentially is going to split the array that is passed into sort of even parts, or at least the variable that you give it. So in this case, if you give it a 2, then each sort of subarray is going to have 2 elements, and then anything that goes over that would just be in a kind of a smaller array at the end.
So I think you can
Besides
call
all
it
that said,
I think you could call this a tuple creator. So because it's going to force it to be a specific value. So like whenever you get back to things, they're actually tuples at that point. So you go from an array to tuples, n tuple. So like whatever size you put here, that's going to be the size of your tuple. So if it's 1, you'll just have like a 1 tuple. If you have 2, you'll have I guess a bituple or dituple, and 3 and so forth.
yeah, that's a good way to put it. And so in this case, we're just sort of thinking of these as like cages. We're putting the animals into cages. Yeah, so in this case, we're putting like 3 birds to a cage, 3 mammals into a cage. And then, in mammals, we have humans. We don't want to be caging humans. So we can use types to sort of restrict that down the road, right? But that's something that you can kind of play around with once you're working on this project. And then here we have an error on line 59 where we're printing all the bird wingspans, right? So we have this function partition, and we're actually getting an error saying that it doesn't exist on the type Lodash. So why is that? Well, that's because we actually didn't define it. We're not actually using the typings that came with the package. We're defining our own. And so in this case, since we're using partition, we should define a specific type definition for the function that in this case is going to take a bird array because that's where we're using it, right? So maybe do you want to try to do that, Will?
Yes, I think I also want to show this. Well, no, it didn't work. Never mind. Sometimes you can do that where it's like I know better. But let's go ahead and create, or not create, but open up our type. And is it here? Yes. I'm going to zoom out just a little bit so I can have a little bit more space. All right, so we know a little bit about partition, or actually I don't know anything about partition. I'm gonna just like go here and look at it and see if I can understand what it's doing. So partition, it creates an array of elements split into 2 groups, the first of which contain elements the predicate returns true before, and the other one is all the ones that are false. So it looks like I need to give it a collection. I'm going to assume a collection is an array, or an array-like object, and then it accepts an optional predicate. I think that's what this means. And the predicate, I guess it's defaulting to identity. So like it'll just be itself. So a predicate, it seems like it must be a function, right? That returns, that takes in some input and like you can do something. So maybe it's a callback function. I don't know. Let's see. Let's see how this goes. Actually, was there anything else here? Collection predicate. Yes, here it is right here. Function. The function invoked per iteration. Cool. Let's try and do a typing for this. So we know it's a function. At least I know that. And we know the name, partition. And all right, it takes an array because that's collection. I don't know what it is yet, so I'm gonna just say any. And it also takes in a function called predicate, I think. Is that what? Yeah, predicate. Sorry. I've tried to turn it off, but it won't turn off.
Okay.
Yeah, it's sorry. Sorry if y'all are watching. I am sorry. This is GitHub Copilot. Yeah, I have access to it. So, I tried to turn it off for this. So predicate, and it's a function. So I'm using the little parentheses, and it must return something. I think it has to return a Boolean. And what does it return back to us? It returns an array. Okay, so I'll just use array literal syntax because I don't know what kind of array yet. We're gonna kind of get there. We're gonna get to how this really should be. But for now, the error went away, so that's good.
Mm-hmm.
So how can we make this where it's like more generic?
Well, we could use generics, right?
Okay, all right. So T, I think that's fine. And note here that the compiler is telling us, it's like, hey, you've declared this value. Technically, this is a type, but like you've declared this name, but you're not using it. So you can almost think of this as a value, but like you pass in the type, that's a value. So we'll put T here. And the predicate, I assume that like we need to pass in something in here, right? Like, so maybe we pass in the T, maybe. So like, what should we call this value that gets passed in? Maybe P, and just put T.
Sure. Yeah. I mean, it really doesn't matter, I guess, the name for it. The type is what matters here, right?
Mm-hmm.
So.
Oh, and we need to put T here to finish it off. So like we have a partition that's generic, and it takes in an array of some type, and the function is going to take in each element in that array of type T, and it's going to return a Boolean, and we're going to then return another array of type T mm-hmm. with the same elements that were in the original array.
Mm-hmm. Yeah.
Okay. How does that look? Am I on the right track with this one, or did I miss something?
Yeah.
Okay.
Looks great.
Okay. Oh, wait. No. Remember, according to here, or at least I'm thinking, I assume that these square braces means that this is optional. So I'm going to put a little bit of sauce on it if I put this question mark on it. So now we're more in line with the documentation for Lodash.
Yep, you're right.
Okay, all right, so what else should we do? Let me go ahead and save this. I think that's a good option for now. We'll save. Okay.
Okay, great. So now let's try to make our type declaration more specific to sort of the shapes that we're using in this project, right? So those shapes would be the animals in this case.
Okay, so walk me through it. Walk me through it. I'll drive. I'll type, I guess, but like, yeah.
Okay, so all right, so here we have our random animal declaration file. This is the declaration file for the library, but as you can see, it's sort of very bare bones, right? So we have our get function here. All we really know is it's going to return an animal, and the animal is going to have an animal group that is going to be, and here we have a type alias. It's going to be of type bird, mammal, reptile, or fish via our union types. But that's really all we know, right? So if we were to run this, we would actually see that our library is actually returning a bunch of different types of mammals and birds and reptiles and fish. So the first thing that we can add is, let's start with our mammals, right? So let's declare a mammal interface.
Okay, so we'll do the interface, and we'll call it mammal. Can I not spell? No, I can't, apparently.
There we go. Cool. Yeah, and we know that this mammal is going to have a species associated with it. So let's declare a species for it, and then let's just call this one mammal species for now. So it's going to give an error because we haven't defined this yet, but let's just add that there. And then let's define the locomotion for it. So how does this mammal move through the world? And then we can define mammal locomotion for it.
I think that's how you spell locomotion. Oh.
Locomotion, yeah, cool. And so it looks like you're just missing a comma there.
Oh, no, wait.
All right.
No, I don't think I need a comma.
No, you had it right.
Oh, I do? Okay.
Yeah, you need a comma there.
Okay.
Okay. And now let's say, okay, we need to define what the mammal species are, and then the mammal locomotion. So of species, we have humans, we have horses, we have dolphins, and we have chimpanzees. So Will is typing out an interface here. We actually have some different options that we can go with. So Will, can you think of any of different options that we could maybe use?
A type alias?
Yeah, we could use a type alias for sure. What about an enum? Is that something?
Oh,
that
yeah.
we can use?
Yeah, we can use enum. I forgot, we didn't even go over that type, but I guess we're going to go over it now. So let's do enum, and that's going to be equal to that. I think this is how you do it, or do you not do equal? Is it just like that?
Yeah, no equals.
Okay,
Yep.
and why is this? Let's start. Oh, okay, so enums, you have to do a declare. Okay. All right, so when in a declaration file, if you have an enum, you do have to use declare. You don't have to do declare on interfaces or types, but pretty much anything else you do have to declare. And we're doing that on line 1, where we're declaring a module. And I actually just learned that you had to declare enums. I did not know that until just now. All right, so we have humans. What else do we have?
We have a horse.
Horse. I'll do that.
We have a dolphin. And we have a chimpanzee.
I would just say chimp. I don't know. I don't know how to spell
Sure.
it. Oh, wait, maybe I do. Is it this? Is that how you spell it?
I think there's 2 E's, but I might be wrong. We can
All
just
right,
leave it
yeah,
to chimp.
we'll go with chimp.
Yeah. Okay, great. And then now all we have to do is define the mammal locomotion, right? So we have a terrestrial and we have an aquatic, right? So we have humans, horses, and then we have chimps. Those are terrestrial. And we also have a dolphin, which is going to be purely aquatic, but dolphins are mammals too. So.
All right, so what are my options again?
We have terrestrial and we have aquatic.
Don't judge me if y'all are watching and I've misspelled that. I don't typically write that word. Aquatic.
And what is an enum, Will, exactly?
It's just a set of possible values, of named values specifically. If you've ever used any other language like C# or C or Java, you have just like a finite set of possible values that something can be. In TypeScript, they are a little bit more flexible. You can also have strings like we're doing here. You can also set these equal to numbers. So if you're used to other languages, you can do something like this. And like they don't have to be in order. You can just use whatever numbers that you like.
Okay, great. So let's go back to our other file here and put it into practice.
Okay. Wait, which file are we talking about? The types for Lodash, or are we talking
Well,
about
we'll
here?
get let's go to the all the types file first.
Okay.
We see that we're first sort of filtering out our birds, our mammals, our fish. Right now we're only working with mammals on line 26. So let's sort of make this filter a little bit more specific. Like which type of animal are we working with here? So as we mentioned earlier on, we don't want to use any anywhere, right? Like that we want to avoid using any at all costs, right? This is actually sort of a very interesting thing that comes with TypeScript. We have this ability to use the is keyword. Maybe perhaps this is a little bit more kind of a complex TypeScript idea or out of scope, but it's a very powerful thing to know. So in this case, when we add it as sort of the return type, we are saying, if this function returns true, then we know that the type that was passed in this case animal, is going to be of type any. Okay, but in this case, any is not very useful. So that's where we want to actually change it and sort of make the type that associated with that object more strict. So let's do that here. In the case of mammals, now we have a mammal interface that we can use. So in this case, when we know that the group is mammal, then we can, there we go. All we have to do is import it.
So I guess I also have to export this first. And now we can import it here.
And that error should go away.
Type predicate's type must be assignable to its parameters type.
That's because our mammal type does not extend the animal type, right? So we need to actually extend that there.
All right, there we go. And now it all works.
Now it works. Okay, I know what we can show. We can show us defining, let's see. Okay, let's define the unique function for on line 64 of the all the types file.
Okay.
Let's define that in Lodash and then add in a generic where we can sort of restrict that unique function to only take numbers, because we know that wingspans are just going to be numbers.
So like just put a number here?
I mean, let's put a generic there, and then in the actual file, in the actual all the types file, we can restrict it by sort of saying, okay, this is going to be a number.
Okay. All right. I've never used Lodash, so I'm sorry. I had to look at the documentation. So it takes an array. Okay. Array. Okay. Oh, that's it. It just takes an array.
Yeah, that's literally it. And then it's just going to return an array as well. Of the same type.
So yes, in JavaScript, yes, but I think we can be more specific and say that it returns a set of T. Here's why. Because it says that it returns a new duplicate-free array. So a set, like it's an array like it's iterable, but like if it's unique, then that means that it's technically a set. So like this is more specific, I think.
Yeah, I think so too. Yeah, that's very good. Cool. All right, so now we have this definition for unique, and as we can see on the left side on line 69 there, we no longer have that error. However, we still can be more specific.
Wait, I'm looking. I'm sorry.
On the unique wingspans.
Oh, here. Okay.
Yeah. So we want to print all the unique wingspans of all the different birds that we have, but we know that all of our measurements are only numbers. We're not going to pass in unique strings or unique booleans. We're talking about measurements here. So how can we be more specific about what the wingspans are going to be in this case?
I'm assuming that like we can put like almost like a condition for T, where we can say like T must be this, like T extends, or is extends the right word? Extends number. So like if I were to put wait, where's wingspans here? I think we need to get map so that we can get this type out, so I can like show what I mean. So I'm gonna define map, I think.
Okay, sure. Let's go ahead and define map as well.
I had to look at the docs. I'm sorry. Oh, just map. A collection and a iterative. Okay, I don't know what that is. We'll do T array of type T, and then whatever that is, iterative. I can't even spell that. Iterative.
Iterate T, yeah, like it's the iterator and the iterate T. So in this case, it would be like.
Is that another array, or is that just a function?
It's a callback, right? So this is what's going to, like every element in the array is going to pass in as an argument to the callback that we specify. So there's going to be a function, and we can define the type of the iterate t as well.
I don't know what it returns. I'm just going to put t for now. And I know it returns an array. So we'll just say t that. So what should this
Let's
type
see.
be?
So it wouldn't return t because t would be the iterate t type.
Okay.
So in this case, like say we have a bird, right? The bird has a property wingspan.
Mm-hmm.
The bird is an object. The wingspan is a number. And what we want is we want an array of only the numbers that are unique. So in this case, we know that's going to return a number. So maybe we want to put number in the return type of iterate t. However, we want to the iterate t. We can say, oh well, this is going to be the same type that we pass in. So in this case, it would be bird, but for this generic purpose, it would just be t.
So I guess E and then T, like something like that?
Yeah,
Or
I think
X?
that would work.
Okay. Okay.
Yep. Sweet. Okay. And then obviously, like if we wanted to do something else with map, do you want to talk a little bit about overloading, right? Because right now we're sort of limiting what this, in this case, this callback we would return a number. But in the future, we might want to reuse this load dash function where the callback function returns a string.
Yeah, so overloading is pretty simple. You just rename, like you just redeclare the same function essentially. In fact, I'm not even gonna type it. I'm just gonna paste it here. And let's say we wanted to return a string. So now, we can have two different functions, and we can have it return a string or a number, and it's effectively overloaded. But
Yeah.
there's another way that we can accomplish this. We can do another type variable. We can say k, for instance, and then we can put k here. So now, if we have a map, we can actually specify here. It's going to be of type whatever this first thing is, and then we can say, well, what is the first thing? Map bird. Is that the type here? I'm not sure what the type is.
Let's see. So it would be bird.
Okay.
It would be of type bird,
Oops.
which we haven't defined yet.
Okay.
But
I feel like
we already defined mammal, so like think of it the same way.
I thought that there was a way to like not have to pass in a t and have it be inferred from the thing that's passed in. Like I thought that was a thing, but maybe that's not a thing. At least in C# that's a thing where it's like you can kind of like infer it and like don't have to pass it, or maybe I'm just full of it. I could be that too.
I don't know. I've always known where like this is the way that you do generics, but
I'll
yeah.
undo it because I don't actually know. I will say that like this is still of type any, so it's not understanding that birds with wingspans sub-0. Wait, why is that sub-0?
Because I think it's just because of the way that partitions are returned, right? So we're just returning the first partition.
Okay.
Yeah.
Okay.
So it's any because we haven't defined the type of bird, right? That interface doesn't exist yet.
All right. So we need to define that, I guess.
Sure.
Okay. What does this interface look like? Is it just
Okay.
called bird, like that?
So it would just be the same way that we did model. We'd be doing a bird. It's a type of animal, so we would extend the animal.
Okay.
And then again, like we would have a species, and that species would be, a bird species type. I guess we can just define it directly. It would be a ostrich, a penguin, an owl, or a duck.
We'll go with these two for now, I think, unless we need to do the other ones.
No, yeah, it's just to get the idea across, right? And this is just a different way than what we did for mammal, right? We're just showing that you can do it either way here.
Okay.
And then we want to have a wingspan, right? So let's add a wingspan. And this wingspan is a measurement of the wings, so that's going to be a number.
Okay.
And then we have two more properties. So we have whether it's aquatic or not, right? So a duck is aquatic, penguin is aquatic, but not an ostrich. And exactly, that would be a Boolean. And then we have a flying property or a non-flying bird. So that would be Boolean as well.
All right.
Cool.
And I guess
All
I
right.
need to type all birds to be is bird.
Mm-hmm.
And I guess I gotta import it. So now all birds is a bird array.
Yep.
And where was I? Here? Birds with weeks. Okay. Partition. The type for partition must be wrong.
Well, we have in the iterate t, we're defining the bird as any. So let's change that and to be more
Oh,
specific.
okay. Actually, I don't even think you have to do it now. I think type inference should tell you. So it's a
There we
bird.
go. Yep, that's true. Yep, you're absolutely right. Okay, great. So now birds with wingspans, what type is that? Okay, so now we're getting an error. Um, yeah, so let's actually pass in our generic here. Um, so that would be type bird, and I think that okay.
Let's look at the error. No
Yeah,
overload
let's
matches this call. Array bird iterate t x bird to number. Bird gave the
bird.
following error. Oh, okay. Argument of type bird is not assignable. Okay. This. Wait. Hold on. Oh, this bird. Okay. Maybe I'll just do that. Oh, it doesn't know what bird is. I'm gonna remove this for right now. Nope, didn't do anything.
Okay. All right. Well, we can figure it out. This is part of the TypeScript process. So let's just read the error again. Argument of type bird is not assignable to parameter of type bird array. Okay. Um, so it looks like
I know
this
why.
first. Yeah.
I know why this is
Okay.
happening.
Go ahead.
Because all right, let's just get rid of this. I don't think we need that. I'm gonna type bird is not assignable type. Okay, so I guess we do need this. My thinking is that because this is a bird and not a bird array, that like it's complaining because wait, why is this? Actually, I don't know.
Yeah.
Never mind.
I think birds with wingspans index 0 is actually a bird. It's not an array as I thought. So partition. Oh, that's weird. So there it's being defined as a bird array, but it thinks that it's a bird. That's bizarre.
So what do we expect this to be? Birds with wingspans should be a bird array, correct? Like that.
It should be, yeah. So yeah, that's actually a good point. I think it would be an array of bird arrays. So it would be a bird array array.
A array of bird array.
Yeah. So if we look at partition again in Lodash, we could probably get a better idea of what it's doing, right? I think that might be useful. So creates an array, splits it into two groups, the first of which contains elements predicate, returns truthy4, right? And so if we look down there,
Ah,
let's find an example where it's, okay, yeah, there you go. So it's an array containing
it's going to be a
two
tuple array.
arrays.
It's a tuple array. So it'll be an array of t and t, tuple.
There we go.
Yeah. And then if you come here, that's actually false here. We're not going to do
Yeah,
that.
let's get rid of that.
But yeah,
Okay.
there it goes. It's a bird, except it's actually not. It's a that. So
There we
yeah,
go.
there we
Okay.
go. All right.
Nice, nice. Um,
So I wonder if we even
okay.
need this anymore. If it'll just infer it. Yeah, we don't need that anymore. Because it knows. And that's what I meant. Like I thought that you didn't have to specify it because it gets it from the first argument.
hmm
So yeah, I guess that's
So
fine.
let's hover over bird and see just in the iterate t.
Where's
Let's
bird?
see
Oh,
if
okay.
the type inference is working there correctly.
Yeah.
Okay, beautiful. Yeah. So this is an example of where TypeScript, or in this case, type inference is super powerful. We don't even have to sort of worry about what it's doing there.
Okay. All right. All right. So now Wingspans is upset. Wingspans is a bird array. It's, but it shouldn't be. That means that uh, maybe map is wrong. Yeah, map is wrong.
Yeah, yeah,
Uh,
map is
so
wrong. Correct.
so I think that we do need the other thing. We'll call it K, and then this will be K. And Wingspans is unknown. So I think we will have to actually be specific in what it is. So the first thing is going to be a bird array, I think. Then the second thing is going to be a number.
Uh, no, I think it would be a bird, not
Just
a bird
bird.
array.
Okay. Yeah, you're right. So now we get back a number array, and that was it.
Yep.
So yeah,
So
we have to
can
do
you
that.
dive a little bit deeper into what the K is doing here?
Yeah.
Well,
So um, you can pass. You can think of this as variated, right? You can pass as many like type variables inside of these chevrons. So just like when we had t, where we kind of substitute all the t's, we can also do that for any other types of variables. So I just defined another one called a k. You can name these whatever you like, by the way. I'm using generic names because we don't know. It's customary to just use t. And I'm using k just to give a different type. So I know that this iterate T is going to accept, it's a callback that accepts, the type T, in this case bird, but it's going to return back a number. And I want to make sure that like I can say in the map that, wait, where's the map? I want to make sure that I can tell TypeScript, oh, by the way, this thing that I'm doing is going to return a number. And I'm saying that this number is going to be an array. And that's what I'm doing here. So it's like I have K, and then I put K here. In fact, I could do one better and put K here. So now this is fully generic, where whatever type that I pass for the second type is going to be the type that the callback returns, which is going to be the type that the function returns. And I think that because I did that, I want to say I don't even need these two anymore, I think. Yeah, so I don't even need the angle brackets anymore. It can get it from the fact that we know that it's a bird, and we know that this thing is a number. And it's going to, when I say this thing, I'm talking about wingspan. We know that
The
this is a
wingspan,
number.
yeah.
So
Just gonna infer correctly.
Yes.
What the types are. Yep.
Yes. Was that a decent explanation? Was that okay?
Yeah, that was great. Yep. Okay. All right. Well, thank you everybody for joining us. We hope that this was helpful and you learned a little bit more about TypeScript. We do have the project linked in the notes. So, all right, we encourage you to follow along there and try to do all the different exercises that we have and play around with the example project and try to get everything working. So thank you so much for joining us, and until next time.
Yeah, I also want to add that I will be observing the repo. I will leave issues open. So if you all have any questions, feel free to drop them there or comments. And this is in an effort to make this as interactive as possible. Like I said at the beginning, we're not together. So this isn't a normal workshop. So in an effort to try and make it a little bit more normal, I'll observe issues for about a week after this goes live, and I'll try to answer any and all questions. So I appreciate you all for listening, and I hope that you learned something.